Hello everyone. Let us continue the part 3 of today's class. Okay, in the beginning, let us see new announcements. Okay, first one is the midterm exam announcement. Hello everyone. According to the school calendar, April 11th to 17th, 2022 is midterm exam week. Our midterm exam takes the form of taking home. I will upload the exam questions to the eCourse2 website on April 11th, 2022. Please send the answers to my email address comwliu@ccu.edu.tw at the latest by April 17th, 2022. Please note that this is still an exam and you are not allowed to discuss it with anyone during the answering process. Sincerely, Wei Jian. Okay, the next new announcement is the slides of chapter 2 has been updated. Version 2022-0401. Hello everyone. I have uploaded the newest version of slides of chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning, course content, slides, chapter 2 reinforcement, learning for resource allocation in cognitive radio networks, slides 2022-0401.pdf. Compared with the previous version, the updates in this version include: first, page 21 underline quality of service and QoS. 2. Page 22 underline throughput. 3. Page 22 underline objectively. 4. Page 22 underline application layer. 5. Page 22 underline end-to-end distortion. Best regards, Wei Zhen Liu. Okay, the next new announcement is the handout of chapter 2 has been updated. Version 2022-0401. Hello everyone. I have uploaded the newest version of handout of chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning, course content, handouts, chapter 2, reinforcement, learning for resource allocation in cognitive radio networks, handout 2022-0401.pdf. Compared with the previous version, the updates in this version include: first, enlarge figure 3, page 21, add problems 1 to 4 and their solutions. 3. Page 22, add problems 1 to 6 and their solutions. 4. Page 22, add problem 7. Best regards, Wei Zhen Liu. Okay. So next, let us continue our progress. Okay, please turn to page 20 of the slides of chapter 2. Okay, in the second part of today's course, we have taught to G0P. Okay, this term. G0P is the channel gain from the PU, that is, primary user to the primary base station, BS. Okay, let us go to figure 2.1 to see G0P. Okay, here is the G0P. It is the channel gain from the primary user to the primary base station. Okay, back to page 20. Okay, so gamma 0P is equal to gamma 0P is the signal to interference plus noise ratio SINR of the PU, okay, of the primary user is equal to G0P times P0 over summation I is equal to 1 to capital N, where capital N is the number of secondary users, and GIP, okay, GIP is the channel gain from SUI, that is secondary user I to the primary BS, primary base station. Okay, let us see the figure 2.1. Oh, okay. So let us go to figure 2.1. Okay, GIP is equal to the channel gain from the secondary user I to the primary base station. Okay. Okay, let us go back to page 20. Okay, and GIP times PI. PI denotes secondary user I's transmit power. Okay, where 1 is smaller than or equal to I, and I is smaller than or equal to capital N, and plus sigma square. What is sigma square? Okay, in the on page 19. Okay, sigma square is the power of the additive white Gaussian noise, AWGN. Okay, which is greater than or equal to gamma 0. And gamma 0 is the primary user's required SINR threshold as determined from the underlay DSA configuration. Okay, what is DSA? Okay, let us search for DSA. Okay. Okay, on page 3, DSA means dynamic spectrum axis. Okay, in chapter 1, I have told you what is the dynamic spectrum axis. If you forget it, please review the handout of chapter 1. Okay, let us go back to page 20. Okay, and when you see an interference scenario like this, or when you see an equation of an SINR, you must ask yourself a very important question. Who interfere who? That is, who is the subject and who is the object? Okay, please see the blackboard. Okay, because I do not have a blackboard now, let me use the Microsoft Word instead. Okay, so on page 20, who interfere who? Okay, who is the subject and who is the object? Let us go back to the slides. Okay. In this equation, we know that the numerator is the received signal power. Okay. And in the denominator, the first term is the interference power, and the second term is the noise power. So let us see the received power is received signal power is equal to G0P times P0. Okay, so let us go back to figure 2.1. Okay, G0P times P0. So the received signal is received by the primary base station. Okay, so the primary base station is the receiver. So it is the objective. Okay, so the object is the primary base station. And who is the subject? Okay, let us see the slides. And back to page 20. Okay, in the denominator, let us see the first term. It is the interference power. The interference power comes from Pi, where Pi denotes its secondary user I's transmit power, whereas I is equal to 1 to capital N. Okay, so we know that the subject is all secondary users. Okay, subject is Rn secondary users, or you can say all secondary users. Okay, this is very important. Okay, next page. Similarly, for secondary user I, the corresponding SINR is expected to satisfy the condition. Okay. Oh, one more thing. Oh, sorry. So in equation 2.1, what direction do we consider? Okay, let me write on the whiteboard. Oh, sorry, Microsoft Word. Okay, problem. Another problem. Okay, say problem 2. Okay, and this is problem 1. Okay. What is the communication direction? Uplink, downlink, or both? Oh, sorry, both. Okay. Okay, so what is the communication direction? Uplink, downlink, or both? Okay, let us see the figure, the slides. Okay. Okay, let us go to the figure 2.1 again. Okay, because the transmitter is the primary user and the receiver is the primary base station, so the direction of the communication is uplink. Okay, so we can know that the solution is uplink. Okay, here is solution. Okay, bold face. Here, bold face. Okay. Okay, next let us go back to the slides and go to page 21. Similarly, for secondary user I, the corresponding SINR is expected to satisfy the condition. Okay, gamma IS is equal to GIS times PI. Okay, GIS is the channel gain from secondary user I to the secondary base station. Let us go back figure 2.1 and see again. Okay, GIS is the channel gain from the secondary user I to the secondary base station. Okay, go back. And times PI, and PI denotes the secondary user I's transmit power, and divided by G0S. Okay, G0S is the channel gain from the primary user to the secondary base station. Okay, let us go back to the figure 2.1 again. Okay, G0S is the channel gain from the primary user to the secondary base station, which is not plotted in this figure. Okay, go back. And plus summation I is equal to 1 to capital N. GIS, okay, we have just explained what is GIS times PI. Okay, we have just explained what is PI. And plus sigma square, which is the power of the AWGN, which must be greater than or equal to gamma I. Okay, and gamma I is secondary user I's required SINR threshold determined from quality of service QoS goals. What is the quality of service QoS? Okay, let us see the handout. Okay, and search for QoS. Okay, page 21, problem 1. What is quality of service QoS? Solution: quality of service QoS is the description or measurement of the overall performance of a service, such as a telephony or computer network or a cloud computing service. Okay, we will explain what is cloud computing in the next problem. Okay, cloud computing is also a very important technology nowadays, particularly the performance seen by the users of the network. Okay, problem 2. What is cloud computing? Solution: cloud computing is the on-demand availability of computer system resources, especially data storage, cloud storage. Okay, for example, the Google Drive or provided by Google is a kind of cloud storage. And computing power. Okay, let me give you an example. Okay, for example, in Taiwan, there is an organization called National Center for High Performance Computing, 国家高速网路与计算中心. And okay, let me convert to English. Okay, please wait a minute. Okay, because Oh, okay, good. So the core services including the supercomputer and platform service including this. Okay. For example, the Taiwan Computing Cloud. That is, you can pay some money to this organization, to this National Center for High Performance Computing, and use the computer provided by this organization to perform some computational tasks. Okay. So this is the handout. So this is the computing power without direct active management by the user. Okay, please see figure 5. Okay, let us see figure 5. Okay, in figure 5 we can see that here is a cloud here, and in the cloud it contains application such as monitoring, content, for example, news, and collaboration, and communication, and finance. And the cloud also includes the platform. Okay, for example, object storage, identity, runtime, queue, and database. And finally, the cloud also includes infrastructure such as compute, or we should say computers. Okay, and block storage. Okay, like Google Drive and network. So we can use many kinds of devices to access this cloud, such as laptops, servers, desktops, tablets, and phones. Okay, so figure 5 shows the cloud computing metaphor. Okay, what is metaphor? Okay, let us search for the metaphor. Okay. Problem 3. What is metaphor? Solution: an expression often found in literature that describes a person or object by referring to something that is considered to have similar characteristics to that person or object. Okay, this is the metaphor. Okay, let us go back to figure 5. Okay, the group of networked elements providing services. Okay, providing services need not be individually addressed or managed by users. Instead, the entire provider-managed suite of hardware and software. Okay, so this is this cloud. Okay, can be thought of as an amorphous cloud. Okay, what is the meaning of this word, amorphous? Okay, let us see the. Okay, search for within this handout. Okay, amorphous. Okay, problem 4. What is amorphous? Solution: having no fixed form or shape. Okay, so let us go back to the slides. Okay, from quality of service QoS goals. So here is another interference scenario. So again, you must ask yourself a very important question. Okay, it is 25 minutes. And see you next time. Goodbye.